Okay, this is a brief introduction for our challenge. And now I will give the microphone to Professor Lantian Li from Tsinghua University in the BUPT. He is a major people of our challenge, and he led the technical staff of our challenge. And he will give an overview of what we have achieved in the challenge. Okay, can you hear Professor Li?
Thanks, Professor Wong. Can you see my slides? Yep. Okay.
Yeah. Please go ahead.
Okay. Thanks. Hello, everyone. I'm Lantian Li from Tsinghua University and BUPT. And today I will share with you the technical report of SRC 2022. Okay. This is the outline of the report. And firstly, let's review the data, tasks, and baselines of the challenge. Okay. As mentioned by the Professor Wong, recently our speaker recognition community is attempting to solve the more challenging task that is recognizing the speakers in the wild, right? And a key feature of this task is that the speakers and the recording conditions are fully unconstrained, leading to more complex variations, including the intrinsic variations and extrinsic variations. And multi-genre scenario is perhaps the most challenging scenario for speaker recognition, as it involves nearly all the complex variations you can imagine. And here illustrates an example. Speech of one celebrity is recorded in multiple genres. And we argue that the good performance on the multi-genre is a sufficient and necessary condition for practical success of speaker recognition research. So now that is the origin of the celebrity site. Okay, and the whole collection pipeline composes two stages. Okay, and the first stage, audio segments of the person we interest were extracted from a large amount of raw videos with automatic tools. And in the second stage, a human check was employed to remove incorrect segments. And for the first stage, it is largely borrowed from the collection pipeline of Work Celebrate, and it mainly consists of 5 steps, including POI list design, pictures and videos download, detection and tracking, and mouth-speech synchronization and speaker diarization. Okay, and here is the profiles in celebrity site, and it was collected from multiple media sources, leading to 11 multiple genres. It contains more than 600,000 utterances from about 3,000 Chinese celebrities. The total speech duration is 1,300 hours. So the celebrity site can be used to perform multi-genre training and test. And with this site, we set up this speaker recognition challenge, SRC. Okay, and the first task of SRC is the general speaker verification task, and that is to determine if the test utterance is spoken by the claimed speaker. And moreover, it involves 2 tracks, the fixed track and the open track. Okay, and for the fixed track, only the training set of Celebrate is allowed for training and tuning all the components of the system. And this track is designed to compare different techniques under the same data resource. And for the open track, any data sources can be used for developing all the components of the system. And this track is designed to examine the performance of frontiers of the present technologies. Okay. And the second task is speaker retrieval. This is the new task. The goal of this task is to find out the utterance spoken by the target speaker from large data pool given enrollment data of the target speaker. So the data set contains 2 parts: the target speaker's enrollment data and the large data pool, which involves utterance of the target speakers as well as a large amount of non-target utterances. Okay, and in this task, any data sources except the Celebrate evaluation site are loaded for system building. And we also set up a development site and an evaluation site for system development and evaluation. Okay, so this is the task information. And for task 1, speaker verification, there are 2 popular metrics for performance measurement. The first one, the primary, is the minimal detection cost function. And the secondary is the equal error rate. Okay, sorry. And for the task 2, speaker retrieval, it is measured in terms of mean average precision, which is the standard metric in information retrieval field. Okay, and To demonstrate the training and evaluation required by the challenge, we also prepared several baseline systems for participants. The first one is developed by the source toolkit, ASV Subtools. Subtools is a professional toolkit for speaker recognition and language recognition, and it is published by Xiamen University and a talented soft company. Okay. And the second one is developed by the source toolkit Sunny. Sunny is a lightweight toolkit for speaker recognition. It is published by Tsinghua University. Okay, above is the brief of data, tasks, and baselines of the SRC. And in this part, let's look at the technical summary. Okay, there are 16 teams submitted the system description, and next to these system descriptions, we summarize some representative techniques from different system components, including data processing, feature selection, seed selection, neural backbone, coding strategy, auxiliary design, loss function, training strategy, backend scoring, and system fusion. Okay, considering the time limitation, so let's discuss several technical highlights. Okay, the first one is speed perturbation in data processing component. And many teams prefer this approach to expand the number of speakers, and the utterance with a new speed will be considered from a new speaker. And team 1-to-1 presents an amplification study on speed perturbation, and the results show that this approach is quite effective. Okay, and the second one is improvement of A-kappa TDN neural backbones. As we know, A-kappa TDN is a popular neural backbone, and it consists of 2 key modules. The first one is the resonate block to capture multi-scale receptive fields, and the other one is the squeeze and excitation block to achieve channel-wise interaction. And based on the basic A-kappa TDN backbone, there were teams attempt to make some improvement. For example, Team 9 employs a dynamic convolution network to replace the basic resonate block. This improved network involves an attention module to dynamically adjust the weights of each convolution layer. And the team 70 introduced multi-scale 1D convolution layer before A-kappa TDN, and these convolution layers can provide multi-scale spatial information. And the team 106 adopts a multi-scale frequency channel attention mechanism to obtain high resolution feature and from the short utterances. Okay, so this is some variants from the A-kappa TDN. And another favorite backbone is resonate, right? And based on the basic resonate backbone, several teams make some exploration. For instance, the team 22 and 82 attempt to make it deeper, and the performance seems good. And the team 53 integrates the channel-wide attention with multi-pass network to capture cross-channel feature correlations. And team 106 proposes a gated frequency channel attention module to get better frequency and channel attention in the resonate. Okay, and say the next is pooling strategy. Okay, and for the pooling component, it maps the frame level feature sequence into a fixed length continuous vector, right? And a few teams propose some new pooling strategies. For example, the team 42, okay, proposes a global local statistics pooling combination along with the hybrid neural backbones. And the other one is the team 70 indicates the attentive stats pooling and some pooled convolution pooling. And the former one focuses on the channel-wise utterance representation, and the latter focuses on the larger global utterance representation. So this is two pooling strategy combination. Okay. Okay, the next one is a auxiliary design. Okay, and the main goal of the auxiliary design is to eliminate the gyro interference, and learn gyro invariant speaker representations. And for instance, the team 9 uses a gradient reverse layer to decouple speaker information and gyro information. And the team 28 concatenates a speaker embedding and gyro embedding to obtain the final embedding. And team 42 designs a new loss function to minimize the mutant information between the speaker embedding and the gyro label. And the team 106 designs a simple generative model on speaker embedding to describe the uncertainty information such as gyro and noises. Okay, and the next is loss function. Yeah, the margin-based loss function, margin-based softmax method, perhaps is the most favorite. And to further improve the system performance, many teams introduce some techniques. And for instance, the subcenter method is employed to help model elevate the effect of noisy and low quality samples. And the top and in inter top-can penalty and at phase was adopted to choose negative samples or margin based on data quality to improve the model training process. Okay. And finally, the last one is backend scoring. And okay, on one hand, many teams focus on how to leverage multiple enrollment utterance. For example, team 57 employs alpha query expansion based technique, RQE, to the enrollment embedding aggregation at the test time. And the performance is drastically improved. That's great. And the team 106 employs the skilled dot self-attention and feed-forward self-attention networks to learn the interrelationship of each enrollment utterance. Okay. And on the other hand, a few teams attempt to yield the quality-aware score collaboration based on quality metric functions. For example, the team 53 defined a quality metric function based on the duration of the test speech to achieve score collaboration. Okay, this is the backend scoring method. All right, above is the technical summary, and all these system descriptions has been published at our challenge workshop webpage. So yeah, next part is the system analyze, and we will present a systematic analyze on each task and each track. Okay, now firstly, let's look at the multi-shower analyze on task 1, speaker verification fixed track. And we select 5 showers which had the most number of test trials, and then compare our baseline system and the top 3 system. Yeah, it can be observed that different genres present obviously different performance, and the best performance genre is speech, and the worst performance genre is singing. And moreover, under different genres, the top 3 systems show different advantage. For example, the first place system obtained the best performance on interview and indeterminate genres, and the second place system obtained the best performance on speech genre, and the third place system wins on the singing genre. Okay, so different systems show different advantage under different genres. Okay. Yeah, and furthermore, to make more fine-grained comparison among the different systems, we propose a new evaluation toolkit named Configuration Performance Map, CP map. And this figure illustrates the CP map of the baseline system. And in this map, each point is a subset of the 4 test trials defined as a trial config. And for the x-axis, the scores of the target trials are gradually increased from left to right, indicating the target trials are from hard to easy. And for the y-axis, the scores of the non-target trials are gradually decreased from bottom to up, indicating that the target trials are from hard to easy. And the color in the map represents the metric values corresponding to each trial config. And with this CP map, we can analyze the speaker verification system in an all-round way. Okay, so we plot 4 CP maps of our baseline system and the top 3 systems with the minimal DCF metric. And for more clear comparison, we fixed the trial configs produced by the baseline system, and then plot the relative change ratio between the baseline system and each top system of each trial config, and we call it dirty CP map. And by this dirty CP map, we can get detailed comparison among different systems. Okay, and it can be observed that the top 3 systems clearly outperform the baseline system, especially in the easy normal regions, that is orange area. And however, this advantage becomes marginal in hard regions, that is green area. Okay, and we also plot the CP maps and dirty CP maps of these systems with ER metric. And it can be observed that the top 3 systems outperform the baseline system on the majority of trial configs. And the larger proportion of high performance area, blue area, reveals that there are a large amount of easy trials. Okay. Yeah, and yeah, the next let's look at the genre distribution of easy, normal, and hard trials config respectively. And we randomly sample 3 points from the CPU map. That means the 3 config, okay, representing easy, normal, and hard trail config. And then we compute the proportion of each shower, each trail config, as shown below. The left subfigure is the shower distribution of target trails with these 3 trail configs, while the right subfigure shows the shower distribution of the non-target trails. Okay. And firstly, let's look at each shower of 3 trail configs. And the shower distribution of target trails plays a key role, and the shower distribution of non-target trails looks uniform. Okay. And technically, different showers show different levels of difficulty. And for advertisement, moving theme, it occupies a large proportion in hard trail config than that of easy trails. While interview, recitation, speech occupy more proportion in easy trail config than that of hard trail config. Okay, and considering different showers have different numbers of trails, so we first make a shower-wise normalization, and it is more clear to say that advertisement, movie, saying occupy a large proportion in hard trails, and the interview, recitation, speech occupy more proportion in easy trails. So this first demonstrates that different showers have different level of difficulty in speaker verification task. Okay, next, let's make the multi-genre analysis on task 1 as we open track. And it shows the similar observation as the fixed track, and different genres present different performance, and the top 3 system shows advantage on different genres. Okay, and we further also plot CPU maps and dirty CPU maps of these systems. Similarly to fixed track, the top 3 system is superior to the baseline system, especially in easy normal regions. On average, this advantage becomes marginal in the hard regions. Okay, and finally, we compare the high rank systems from fixed track and open track, and it can be observed that the system in the open track is always superior to system in the fixed track. And this indicates that more training data may be more better performance, especially on the easy normal trail configs. Okay. Yeah, finally, we compare the performance of the visible evaluation, that means the white box evaluation, and the blind validation, that is the black validation test. Yeah. And for the visible, or we can see the white evaluation test, it focuses on the technical innovativeness, while for the blind, or we can see the black validation test, it uses to verify the practicability of these techniques. So we prepare a small validation site, which consists of 56 new speakers, and then allow the participants to submit the result on the validation test with their final submission system. Okay, here is the illustration of the performance of evaluation test and the validation test. And we argue that if the system is robustness, okay, and the performance on the evaluation side and the validation side should be quite similar. So that is the green line. The green line is the ideal line. And then we make a linear regression on these evaluation and validation pairs and obtain the red line, okay? And it can be observed that for both AER and the minimal DCF metrics, the slope of the red line is larger than 1, which is the slope of the green line, okay? And this means that over-tuning problem occurs among these systems. Okay, and we also plot the evaluation validation pair from the open track systems. And it also shows that the slope of the red line is larger than 1, indicating the over-tuning problem. And besides, we mentioned that there is a clear difference between the EER and the minimal DCF metrics. And this indicates that maybe simply using these 2 measurements may lead to some performance bias, sometimes maybe unconvincing. Okay, and yeah, so finally we make the comparison between the evaluation test and validation test on different showers. And it can be observed that for interview and speech showers, performance on evaluation site and validation site are very close, okay? And this indicates that systems on these genres have good generalizability, and on other genres lead to overfitting. All right, and next is the system analyzed on task 2, speaker retrieval. Yep. Firstly, we make the comparison of the baseline system and top 3 systems, and we compute the top 1, top 3, and top 5, top 10 retrieval counts. of each system. Sorry. And it can be observed that the first place system can retrieval target utterances from different genres, and each genre seems okay, seems good. While for the second place and third place systems seems a bit biased to interview genre. Then we make the comparison of different genres, and it's clear to say that these systems have different capability to handle different genres. And overall, it can be observed that all these systems are good at retrieving interview genres, while fail to sing genres. Okay, and finally, let's discuss the next thing SRC. And firstly, we will advocate the pre-evaluation, that means the white box evaluation, and post-validation, that is the black box validation model, to verify the innovativeness and the practicability, especially on speaker verification tasks. And furthermore, for the speaker verification task, we will employ more convincing and all-round evaluation measurement, such as CP-map, and not just the minimal DCF and DER. And for the speaker retrieval task, we will not only compare the retrieval precision, but also consider the computation complexity, including time and memory costs. And moreover, we hope to design other new tasks. For example, for these multi-speaker genres, such as interview or the entertainment, we will design the speaker localization and recognition task, specifically, firstly, identify where the target speaker resides, and then perform speaker recognition with located segments online. Okay. Yeah, many thanks. That's all.
Okay, thank you very much. So lots of information. Don't worry if you're confused by some of them. We have 3 opportunities. First of all, you can post your question on the chatting box, and then we will have volunteers to collect the questions, and we will discuss them in the final free discussion phase. And also, some technologies mentioned by Professor Li will be presented by our guest presenter. And also the technical report will be published on our website. So you have a chance to look them through carefully.